Hey everyone, welcome back to the channel. In today's video, I will walk you through an exciting project where I will forecast stock prices using vector auto-regression model, also known as VAR model. But you must first know what auto-regression means. Auto-regression means predicting something using its own past values. The AR, that is auto-regression model, is a way to make those predictions. It uses past values to calculate the current ones. The VAR model is like upgraded version of AR model, but instead of using just one variable's past values, it uses multiple variables that affects each other over time. So as a first step, I have imported all the necessary libraries like NumPy, Pandas, Matplotlib and yfinance. Then I have collected historical stock prices data from Yahoo Finance using yfinance library. I have selected the data from February till April 2025 for the stock ticker MYRG. Then I have performed some basic operations like resetting index, renaming the columns, setting index column as a date. Now let's see the different columns that are actually present in our data set. Open column means the prices at which the stock first traded when the market was opened. High prices means the highest price the stock reached during the trading day. Low means the lowest price the stock dropped during the trading day. Close is the final price of the stock when the market got closed, and volume is the total number of shares that are traded during the day. Once I have got the data, I have removed the volume column and kept only the important price features for the stock: open, close, high and low. Then I have rearranged those columns. Next, I have plotted these four variables to understand how do they change over time. As we are having four variables, so I am creating a subplots with the 2 rows and 2 columns so that I will have 4 time series plotted. So for each of the variable, you will be able to see its change with respect to the time. From visual representations, it seems that high and close time series have some kind of correlation and they are following the same pattern. Before applying any time series model, we'll check for the stationarity and we'll use ADF test for that. ADF stands for Augmented Decay Fuller Test. So ADF is a statistical test that is used to test the stationarity of the given time series. So I will import ADFuller function from the stats models library. Then I will pass each of the series to ADFuller function and will print the ADF test statistic and the p-value for each of the series, and we'll see the output now. For all the four variables open, high, low and close, the p-values are more than 0.05, which makes every series not stationary one. So how can we make the series stationary? We can use differencing technique to make the series stationary. In this technique, we'll use the current values will be subtracted from its previous values. I will difference each of the time series using the diff function and will filter all the values of the same series first row onwards, as 0th row will be having null values due to differencing. I will repeat the same process of differencing each series and also checking its stationarity using ADF test, and we'll see the output now. In this case, after using differencing technique, all 4 time series p-value are less than 0.05, making every time series stationary. And if these p-values are still greater than 0.05, then you will have to do the differencing again to make the series stationary. You can build VAR model on every time series, but for now I will be focusing on only two time series, close and high. Before we use VAR model, we'll see the statistical test called Granger causality test. So this is statistical test that is used to check whether two time series are correlated with each other or not. So I will import Granger causality tests function from stats models library. This function will help you to test whether the time series in the second column Granger causes the time series in the first column. So here I have provided two columns, high and close. So it will tell me if close causes high stock prices or not. Also, you will have to pass the number of lakhs till which you want to check the p-values. Here I have given 4 lakhs. Similarly, I will pass two columns, close and high, to test if high stock prices causes closing stock prices or not. Here also I have given 4 as maximum number of lakhs. So let's see the output now. In the first case, if you can see, for first lakh, second lakh, third and fourth lakh, focus on the p-values. So all p-values for each and every lakhs are less than 0.05, which means that one column Granger causes the other column. And which is that column? That is close column. Granger causes the high column. Then we'll see the next test, which is if high stock prices causes the closing stock prices. So here in this 4 lakhs, we'll see the p-values. So in each and every lakhs, if you carefully see, the p-values are more than 0.05, which means that this high stock prices does not Granger causes closing stock prices. So that's what insight that we have got from the Granger causality test. So we have got strong evidence that closing stock prices causes the higher stock prices, and that's why I will extract two columns from our data frame, high and close, and I will assign that back to our DF as they are correlated with each other. Then I will split the data into train and the test sets. I have splitted data in such a way that last 12 values are in the testing data and the remaining values are in the training data. Now we'll import var and varmax class from stats models library. First we'll provide differenced data, which is training data, to our var model, because this model will provide us the select order function which inputs maximum lakhs to consider. In the select order function, I have provided maximum lakhs as 10 and I have used summary function on top of it. So this summary function will provide us the values of AIC score, BIC score, FPE score and HQIC score. In this case, we will be looking at minimum AIC score. So this select order function highlights the minimum by putting star next to the minimum value in that specific column. So here in this case, minimum value is found at lag number 1 for AIC score. So to train the model, I will pass not stationary training data to our varmax class and order as 1, 0. Here you have to specify the order for autoregression and moving average part, but we are building autoregression model, VAR model, so the moving average part will not be considering. So the value for P is 1 that we have got from that select order function with the minimum AIC score as 1, and the value for Q will be 0. And enforce stationarity is equals to true means the varmax will automatically transform these AR parameters to enforce the stationarity. Hence, we have not provided the stationary data to varmax class. Now we'll train the model using fit function and let us see the summary. So see the results for the equation high and equation close. For the first equation, look at the result. As this is a var1 model, so The higher stock prices not only depends on its previous lag of stock prices but also depends on the previous lag of closing stock prices. Similarly, in the second equation, closing stock prices not only depends on its previous lags but also depend on the previous lag of the higher stock prices. And for corresponding lags, you will be able to see the coefficients, standard errors, z values and the p values. Now we'll focus the values using our trained model. We'll do the predictions for the next 12 steps using getPredictions function. We'll set the date index to this predictions same as our test data and we'll rename the columns as predicted high and predicted close values. Now let us see the predictions. So these are the predicted values for high and closing stock prices. Now as I am having actual test data and corresponding predictions with me, let us try to see all in single data frame. Here you can see the actual and the predicted prices for high and closing stock prices for the given date. It seems that our VAR model has correctly predicted the values as difference in the actual and the predicted values is less. So that's how I have used VAR model to focus the stock prices for multiple features. If you have found this helpful, don't forget to like, share and subscribe for more such data science related content. Thanks for watching and I will see you in the next one.